Hello there, and welcome to Sleepy Galaxy Channel. It is late, or it is nearly late, or it is that hour that belongs to neither day nor night, and you have arrived here anyway, the way people arrive at a window when they cannot sleep. Whatever the hour is where you are welcome. Whatever brought you here, you are welcome. You do not have to explain yourself to a voice, and this voice will not ask. Tonight we are going to spend a long, unhurried while with one of the strangest facts in astronomy, and the strange thing about it is not that it is frightening, it is that it is ordinary. Right now, without any effort on your part, without permission, without ceremony, you are moving. Not only the small motions you can name, the turning of the earth beneath your bed, the long orbit around the sun, the slow carousel of the sun around the heart of the Milky Way. Beyond all of those, our whole galaxy and every galaxy near it are leaning in a single direction, all together, toward a place in the sky we cannot properly see. Astronomers gave it a name that sounds like a myth and means something very plain. They called it the Great Attractor. And the paradox we will hold tonight is this. It is one of the most influential things in our corner of the universe, and after 40 years of looking, we are not entirely certain what it is. We will take that paradox in 4 long strokes. First, how anyone noticed the drift at all, and the small group of astronomers in the 1980s who found it by accident while measuring something else. Second, why the sky itself hides the answer from us behind a curtain of our own making. Third, what we have since learned about the vast basin our galaxy sits in and the deeper mass beyond it. And fourth, honestly and without hurry, what remains unknown. If this kind of thing helps you rest, a like or a subscribe helps the channel reach other people also lying awake at this hour. That is all. Nothing else is asked of you. None of this needs anything from you tonight. You do not need to follow the science. You do not need to stay awake for the ending. Let your shoulders ease down, away from your ears, a little further than you thought they could go. Let your jaw unclench. Let your hands rest wherever they have fallen. Let the weight of you be held by whatever is holding you. Let's begin. Begin with a room, not a room in space, not yet. An ordinary room, the one you are in or one you remember, with its floor and its corners and its familiar, unremarkable flatness. Imagine that the floor of this room is not level. Imagine that it leans by an amount so small that no builder would find it, no spirit level would report it, no ball placed at the center would visibly roll. The lean is a fraction of a hair across the whole width of the floor. You could live there your entire life and swear the floor was true, and you would be honest, and you would be wrong. Now imagine that the room has existed for 13 billion years, and that everything loose in it has had all of that time to answer the lean. Given long enough, the fraction of a hair becomes a direction. Given long enough, everything that can move has already begun moving toward the low corner. Nothing rushes, nothing falls. There is only the long lean of the floor and the patient obedience of everything on it. That is the image I want to leave with you tonight, and I will come back to it many times, turning it over the way you turn a smooth stone in your pocket. The universe our galaxy lives in has a lean. Not everywhere the same, not in one grand direction for all things, but here, locally, in the neighborhood that contains us, there is a low corner of the room, and we have been traveling toward it since before there was an Earth to stand on. Here is what that looks like in the language of measurement. Our galaxy, the Milky Way, together with Andromeda and the Triangulum Galaxy and roughly 80 smaller companions, forms what astronomers call the local group. The local group is bound together, holding its own shape, indifferent to the expansion of the wider universe. And this whole assembly, all of it at once, is moving at something close to 600 kilometers every second relative to the background of the cosmos itself. 600 kilometers in the time it takes to say the number. 2 million kilometers in an hour. In the length of an unhurried breath, in and out, you and everything you have ever touched have shifted by more than the distance from here to the moon and part of the way back again. And you feel nothing. Of course, you feel nothing. This is the first tenderness of the story, and it is worth sitting with before we go any further. Motion without acceleration cannot be felt. What your body registers is never speed, only change in speed, only the push of the car pulling away, the lurch of the lift starting down, the moment the train leans into a curve. Steady travel is invisible from inside. A ship on a level sea, a plane at altitude with the engines settled, a room aboard a very large vessel where the water in a glass does not tremble, 600 kilometers per second, held perfectly steady for the age of the universe, feels exactly like lying down in the dark. It feels exactly like what you are doing now. So the question that occupied astronomers for decades was not whether we were moving. It was, moving toward what? Something has to be doing the pulling. In a universe where mass attracts mass, a coherent drift shared by an entire neighborhood of galaxies means that somewhere ahead of that drift there is more mass than there is behind it. The floor leans towards something, and when they traced the direction of the lean, it pointed to a patch of sky in the southern constellations of Centaurus, Norma and Hydra, a region low in the southern sky, a region that happens to lie almost directly behind the crowded, luminous, dust-choked band of our own Milky Way. Of all the directions the universe could have chosen, it chose the one we cannot see through. I want you to sit inside the shape of that for a moment, because it is one of those facts that is funny before it is anything else, and being amused by the universe is a fine way to loosen the jaw. We are on a train. We would like to know where the train is going. The window on that side of the carriage is fogged, and we are the fog. The obstacle is not distance, and it is not the limits of our instruments. The obstacle is home. The stars of our own galaxy, the drifting banks of interstellar dust, the crowded starfields toward the galactic plane, all of it stands between us and the thing that has been steering us since the beginning. Astronomers call that blocked band the zone of avoidance, and we will spend a long while inside that phrase later tonight, because it is one of the most beautiful accidental poems in the whole of science. But return to the room and the lean, because there is a detail in the metaphor that matters, and it is the reason none of this is alarming. The lean is not a cliff. There is no edge. Nothing in this story is falling. The word attractor sounds like a mouth, like a drain, like something that swallows, and it is none of those things. It is a rise in the landscape of gravity, or rather, a dip, a broad, shallow basin many hundreds of millions of light years across, and we are somewhere on its inner slope, coasting inward at a pace that would take longer than the current age of the universe to complete. We are not being pulled in. We are leaning in. The distinction is the whole of the comfort. And there is a second detail, which we will return to at the very end, and I mention it now only so that it can sit at the back of your mind like a lamp left on in a hallway. The universe is expanding, and the expansion is speeding up, and it is very likely that we will never arrive. The lean will lose to the widening of the floor. We will coast toward the low corner for billions of years, and the low corner will drift away faster than we approach, and nothing will collide, and nothing will be consumed. It is one of the few cosmic stories where the ending is that everything simply keeps traveling. Think about how strange it is that we know this at all. There is no vantage point outside. We cannot step off the floor to see the lean. Every measurement we have ever made of the wider universe has been made from inside a moving room, by beings who cannot feel the motion, using light that left its source before there was anyone here to catch it. And yet patiently, by comparing one thing against another and another, by finding rulers where no rulers were supposed to exist, by arguing for 30 years about the length of those rulers, we worked out the direction and the speed of a drift we have no sensation of whatsoever. That is what the next hours are about. Not a monster in the dark. A room, a lean, and the slow, careful work of noticing. For now, notice only what is easy to notice. The temperature of the air on the parts of you that are uncovered. The particular weight of your head where it rests. The way the room sounds when you stop asking it to be interesting. All of that is happening at 600 kilometers per second, and none of it is disturbed by the fact. You are being carried, and the carrying is level, and there is nothing to brace against. Let that be the first thing we set down. Now let us go back and find the people who noticed. Because nothing in this story arrived by revelation. It arrived the way most true things arrive, sideways, in the middle of a different task, to people who were tired and who had been driving up mountain roads at night for years. The 1970s were a frustrating decade in extragalactic astronomy, and the frustration had a single shape. Everyone could measure how fast a galaxy was receding. That was the easy half. You take the light, you spread it into a spectrum. You find the dark lines where particular atoms have absorbed particular colors, and you notice that the whole pattern has been shifted toward the red end. The amount of the shift tells you the speed of recession, and it tells you with beautiful precision, and it has told us so since Vesto Slipher first noticed it in the 19-teens at a small observatory in Arizona, working alone. Plate after plate, exposures so long they ran across several nights. Redshift was cheap. Redshift was reliable. Redshift you could get from anything bright enough to make a spectrum. The hard half was distance. And you cannot do anything interesting with the first half unless you have the second. Here is why, and it is worth walking through slowly, because everything that follows hangs on it. The universe expands. That expansion carries galaxies apart from one another, and the further away a galaxy is, the faster it recedes, in a smooth proportion first written down by Georges Lemaitre, and then measured by Edwin Hubble. So when you observe a galaxy rushing away at some particular speed, that speed has two ingredients mixed together in a single number, and the spectrum cannot separate them for you. Part of the speed is simply the expansion of the space between you, and that part tells you nothing except how far away the galaxy is. The other part is the galaxy's own motion through space, its own private travel, the drift it has because of what is pulling on it. Astronomers call that second ingredient the peculiar velocity, and the word peculiar here does not mean odd, it means particular, belonging to that galaxy alone, its own and no one else's. So the whole problem becomes an act of subtraction. Measure the total recession from the spectrum. Work out, independently, how far the galaxy actually is. Multiply that distance by the expansion rate to find how fast it ought to be receding if it were doing nothing but drifting with the tide. Subtract the ought from the is. What is left over, that little residue, that stubborn difference, is the galaxy's own motion. It is the swimmer's stroke, separated out from the movement of the river. And the residues are small. This is the part that makes the whole enterprise so demanding. A galaxy might be receding at 10,000 kilometers per second because of expansion alone, and its own private motion might be 600 kilometers per second on top of that. 6%. A whisper inside a shout. To hear the whisper, you must know the distance to better than 6%, and in the 1970s, nobody could measure the distance to a far galaxy to better than about 30%, and often much worse. The whisper was there. The instruments could not hold it. What changed was an idea about shape. Astronomers had noticed, in the way you notice something about a family you have known a long time, that galaxies are not arbitrary. A big elliptical galaxy, one of those smooth, featureless swarms of old stars shaped like a rugby ball or an egg, obeys certain internal rules. The stars inside it move at speeds that depend on how much mass is there, and how much mass is there relates to how large it is and how brightly it shines. Measure the speed of the stars from the width of the spectral lines, and you can predict the true brightness. Compare the true brightness to the faint brightness you actually see, and the difference gives you the distance in exactly the way that knowing the wattage of a bulb and the dimness of its glow tells you how far down the road it is. Two versions of this idea arrived at nearly the same time and changed everything. For spiral galaxies, Brent Tully and Richard Fisher found in 1977 that how fast a spiral rotates predicts how luminous it is. For elliptical galaxies, a related relation emerged connecting a galaxy's size, its surface brightness, and the speed of the stars within it. Neither method was perfect. Each carried an uncertainty of perhaps 15 or 20% for any single galaxy. But here is the thing about uncertainty that makes astronomy possible at all. Errors that are random shrink when you average them. Measure one galaxy and you have a guess. Measure 400 and the guesses pile up and cancel, and what survives at the bottom of the pile is a signal. You cannot know where any one leaf is going. Watch 1,000 leaves and you can see the wind. So a group formed, 7 astronomers, working across observatories in Chile and Hawaii and Australia and California, who between 1980 and 1986 gathered spectra and photographs of roughly 400 elliptical galaxies scattered across the whole sky. Alan Dressler, Sandra Faber, Donald Lyndon Bell, Roger Davies, David Burstein, Roberto Turlevich, and Gary Wegner. They did not intend to discover a hidden mass. They intended to build a better distance ladder, to test the relation, to settle a technical argument. They gave themselves a joking nickname, the Seven Samurai, and it stuck, and it is one of the few nicknames in science that got affection right. The work itself was unglamorous in the way that all real work is unglamorous. Nights on mountains, cold hands, photographic plates, and then, later, the first generations of electronic detectors that had to be coaxed and calibrated and coaxed again. Long drives up switchbacks in the dark with the headlights dipped so as not to spoil anyone's dark adaptation. Weeks of cloud. Data reduction done by hand and by early computers that had to be booked in advance. And through all of it, the slow accumulation of a table, this galaxy, this direction, this redshift, this estimated distance. And then the subtraction. and then the residues, and then the thing that was not supposed to be there. Because the residues were supposed to be random. If galaxies move about because of local tugs from their nearest neighbors, then the leftover velocities should point every which way, up and down, toward and away, a scatter with no preference, the way a crowd in a square mills, with no direction. That was the expectation. That was what everybody assumed they would find, and finding it would have been a fine, boring, publishable result, confirming that the universe was smooth on large scales. What they found instead was that the residues agreed with one another. Galaxies in one whole region of the sky were all moving faster than the expansion said they should, and all in the same direction, and the galaxies on the far side of that direction were moving too, and toward the same place, coming in from the other side. It was not a scatter. It was a current, hundreds of galaxies across an enormous volume of space, all leaning the same way, and we were leaning with them. I want you to feel the texture of that moment, because it is a particular kind of pleasure, and it is a restful one. It is the pleasure of a pattern surfacing out of noise. Anyone who has stared at something long enough for it to resolve knows the feeling. The stereogram that is nothing and nothing and nothing, and then suddenly a shape standing off the page. The name on the tip of the tongue that arrives when you stop reaching for it. The hum of a house that you cannot hear until one night you can, and then you cannot unhear it. For years the numbers had looked like scatter. And then someone plotted them the right way, and the scatter had a spine. They published in 1988, and in the paper they described the source of the pull, wherever it was, as a Great Attractor, lowercase, a description rather than a title. It was Alan Dressler, writing about the work afterwards for a wider readership, who capitalized it and let it become a name. And once a thing has a capital letter, it has a life. The Great Attractor entered the language, and it entered it sounding far more ominous than the arithmetic that had produced it, which was, after all, nothing more dramatic than 400 galaxies quietly agreeing about which way was downhill. Come back to the room. 400 pieces of furniture, scattered across a floor so wide you cannot see the walls, each one drifting so slowly that you would need a lifetime to notice any single one of them move. And 7 people, over 6 years, patiently marking where each piece is, and marking again, and comparing the marks until the marks say what no single piece could have said alone: everything here is going the same way, and the way is that way, and therefore the floor leans. That is what discovery mostly is. Not a flash. An agreement, arrived at slowly, between things that were never asked to agree. Now we come to the curtain, and I have been looking forward to this part, because it is the part of the story where the obstacle turns out to be beautiful. Go outside on a clear night, far enough from towns, and let your eyes adjust for 20 minutes, longer if you can bear it. What appears, once your eyes have given up on daylight, is a band of pale light stretched across the whole sky, thicker in one part, ragged at the edges, running from horizon to horizon like a road seen from very high up. Every culture that ever looked up gave it a name, and most of the names were about milk, or rivers, or roads, or the paths of the dead. It is the disk of our own galaxy, seen edge on, from the inside, because we live within it, about halfway out along one of its arms. And running through the middle of that band, splitting it lengthwise, there are dark lanes. Not gaps, not places where the stars ran out. They are clouds, immense and cold, of dust and molecular gas, lying between us and the stars behind them, and they absorb the light that tries to pass. The grains in those clouds are minute, smaller than the smoke from a candle, mostly carbon and silicon compounds, the ash of stars that lived and died long before the sun condensed. There are not many of them by any ordinary standard. If you gathered all the interstellar dust in a cubic kilometer of the galaxy, you would have trouble finding it. But you are not looking through a cubic kilometer. You are looking through thousands of light years, and thin things become opaque when you stack enough of them. Think of fog. A meter of fog is nothing. You can read through it. 100 meters of the same fog and the streetlight becomes a smudge. A kilometer, and there is no streetlight at all, and there never was, as far as your eyes can testify. Nothing about the fog got denser. There was simply more of it in the way. Or think of the sea. The first meter of clear water changes nothing. At 10 meters, the reds have gone. At 50, the world is blue and dim. At 200, it is dark. And the darkness is not a wall, it is an accumulation. So along the plane of the Milky Way, in the directions where we are looking the long way through our own disk, the accumulation wins. Distant galaxies behind that band are dimmed by factors of 10, of 100, of thousands. Their light is not merely faded, but reddened, because dust scatters blue light more efficiently than red, the same physics that makes a low sun orange through smoke and haze. Whatever is behind the band arrives at our telescopes, reddened, dimmed, and mixed in among the confusing crowd of foreground stars belonging to our own galaxy. Astronomers in the early 20th century, plotting the positions of every galaxy they could find, noticed that galaxies appeared everywhere on the sky except in a broad stripe. The stripe followed the Milky Way exactly. For a while, before anyone understood what galaxies were, this was genuinely puzzling, and some suggested the stripe was real, that our galaxy sat in a genuine void of other systems. The truth was simpler and stranger. The galaxies were there, and we could not see them, and their absence from the maps was a portrait of our own dust. They named the stripe the zone of avoidance. Sit with the phrase for a moment, because it deserves it. It sounds like something from a fable, or from a psychology textbook, or from a map drawn by someone who was frightened. It sounds like a place you are warned about. And what it actually names is not a region of space at all. It names a region of our ignorance. Nothing avoids anything. The galaxies behind the band are not shy and are not hiding. They sit there shining as brightly as any others, doing exactly what galaxies do, entirely indifferent to the fact that between them and one small planet there happens to be a bank of ancient ash. The zone belongs to us. We drew it. It is the shape of our own position, projected outward onto the sky, and we gave it a name that makes it sound like the sky's decision rather than our own limitation. I find that enormously restful, and I want to say why. So much of what looks like an obstacle out in the world is really the shape of where you happen to be standing. The blind spot in your own eye, where the optic nerve leaves the retina and there are no receptors at all, is a hole in your vision that you have never once noticed because your brain fills it in without asking. The thing you cannot see from your chair is not missing from the room. There is a version of humility available here that costs nothing and eases something. The map has a blank on it, and the blank is not a hole in the world. It is a fact about the mapmaker. And here is the sharpest turn of the whole story. The direction of the drift, the direction the entire local group is leaning, the low corner of the room, lies at roughly 320 degrees of galactic longitude and only a few degrees off the galactic plane. Which is to say, almost exactly inside the zone of avoidance. Not near it. Inside it. Of all the sky, of all the thousands of square degrees available, the thing that has been steering us since before the Earth existed sits behind the one part of the sky our own home renders opaque. There is no meaning in that. It is coincidence, and coincidences of this kind are common enough in a universe with only so many directions. But it is a coincidence with a wonderful shape, the shape of a joke told very slowly, and you are allowed to enjoy it. So what do you do when the window is fogged and you cannot wipe it? You stop insisting on that window. This is the practical genius of observational astronomy, and it is worth a few minutes of your attention, because it is the sort of thing that resolves rather than frustrates. Dust blocks visible light. It does not block everything. The grains are roughly comparable in size to the wavelengths of visible light, which is precisely why they interact with it so strongly, scattering and absorbing. But make the wavelength much longer than the grain, and the wave simply passes by, the way a long ocean swell passes a buoy without noticing it. The way a low note travels through a wall that stops a high one. You have heard this yourself, through the floor of an upstairs flat or from a car at a traffic light. The bass arrives and the melody does not. So astronomers changed the wavelength. In the infrared, at a couple of microns, the dimming through the galactic plane drops by a factor of 10 or more compared to visible light. Surveys built for that band, most famously the 2-micron all-sky survey, which mapped the entire sky through the 1990s from telescopes in Arizona and Chile, began to pull galaxies out of the murk that no visible light plate had ever recorded. Further out, in the far infrared and the submillimeter, the dust ceases to be an obstacle and becomes a subject, glowing with its own faint warmth. And then there is radio. Neutral hydrogen, the commonest substance in the universe, emits at a wavelength of 21 centimeters, and 21 centimeters cares nothing whatsoever for interstellar dust. It passes through the galactic plane as if the plane were not there. Spiral galaxies are full of neutral hydrogen, so you point a radio dish at the zone of avoidance, and you listen at that one wavelength, and galaxies appear, one after another, as small bumps in a spectrum, each with its own redshift written into how far the bump has slid from 21 centimeters. Surveys with the Parkes telescope in New South Wales and the Dwingaloo telescope in the Netherlands did exactly this through the 1990s and after, and they found hundreds upon hundreds of galaxies that had never been on any map, including one bright spiral, Dwingaloo 1, close enough to be a near neighbor, hidden all along behind the band. And higher still, in X-rays, the hot gas that pools in the gravitational wells of galaxy clusters, heated to tens of millions of degrees simply by falling inward, glows in X-rays and is not dimmed by dust either. So an X-ray satellite sweeping the sky sees clusters as diffuse patches of glow, and it sees them straight through the curtain. The Rosat All-Sky Survey, conducted from orbit in the early 1990s, mapped that glow across the whole sphere, and there in the zone of avoidance, near the direction of the drift, one patch of glow was large and unmistakable. So the window stayed fogged, and we found other windows. That is the whole method, and it is the opposite of forcing. Nobody wiped the sky. Nobody removed the dust. Somebody asked, patiently, what else the same object might be doing that the fog does not interfere with, and then went and listened for that instead. Let that idea rest wherever it wants to rest tonight. There is more than one wavelength. What is opaque to one way of looking is transparent to another, and the thing behind the fog was never hiding. There is another way of knowing that we are moving, and it does not depend on galaxies at all, and it is the most direct measurement in all of cosmology. It is a measurement of warmth. The universe has a temperature, not a metaphorical one. Fill any empty region of space, far from any star, shield it from everything, and it does not fall to absolute zero. It settles at about 2.7 degrees above absolute zero, and it settles there because it is full of light. Very old light, the oldest there is, streaming through every cubic centimeter from every direction at once, so stretched by the expansion of the universe that it now arrives as microwaves rather than as the fierce glare it once was. Here is where it came from, and it is worth telling slowly because the picture is a restful one. In its first few 100,000 years, the universe was hot enough everywhere that atoms could not hold together. Electrons roamed free, and free electrons scatter light relentlessly, so the whole cosmos was an opaque glowing fog, bright as the inside of a star and equally impossible to see through. Then it expanded, and expansion cools, and at about 380,000 years, the temperature fell to roughly 3,000 degrees, which is the temperature at which electrons will consent to be captured by protons. Atoms formed everywhere, all at once, across the entire universe. The free electrons vanished into hydrogen, and the fog lifted. The light that had been trapped, bouncing endlessly, was suddenly free to travel in straight lines, and it has been traveling ever since, 13.8 billion years of it, without absorption, without interruption, arriving now, tonight, through the roof, through the window, through you. Every cubic centimeter of the room you are lying in contains a few hundred photons from that morning. They are passing through your body at this moment, several 100 million of them per second across the surface of your skin. And they carry no harm and no message, and they have been doing it your whole life and the whole life of your species, and there is not one moment in which you have ever been outside that light. It was found by accident, which pleases me. In 1964, at Bell Laboratories in New Jersey, two radio engineers named Arno Penzias and Robert Wilson were trying to make a very sensitive horn antenna behave, and they had a hiss they could not get rid of. It came from every direction of the sky equally. It did not change with the time of day or the season. They checked their equipment, they cooled their amplifier, and they famously evicted a pair of pigeons from the horn and scrubbed out what the paper later described in careful language as a white dielectric material. The hiss remained. It remained because it was the universe, and they had, without meaning to, put a microphone up to the first morning and heard it still sounding. Now this background light is extraordinarily even. Look in one direction, measure the temperature. Look in the opposite direction, measure again, and the two agree to within a few parts in 100,000. It is the smoothest thing anyone has ever measured. But it is not perfectly even, and the very largest departure from evenness is not a feature of the universe at all. It is a feature of us. One half of the sky is a little warmer than the average. The opposite half is a little cooler by exactly the same amount. The pattern is a simple gradient, warm on one side, cool on the other, and it is called the dipole, and it is about 100 times larger than any other variation in the map. And its cause is not cosmological, it is motion. We are moving through that ancient light, and when you move through a bath of radiation, the light ahead of you is crowded into slightly shorter wavelengths and arrives slightly hotter, and the light behind you is stretched slightly longer and arrives slightly cooler. The pitch of the whole universe is shifted up in front of you and down behind. exactly as the note of a passing siren is, for exactly the same reason. So the sky is warmer in the direction we are going. I would like you to sit inside that sentence rather than past it, because it is one of the most physically intimate facts I know. There is an ancient warmth filling all of space, and because we are traveling through it, it is very slightly warmer on the leading side. Turn your face toward the constellation Leo, and you are turning your face into a difference of about 0.003 of a degree, which no skin could ever register, but which is there, and which is the direct sensation of our motion, translated into the only language the universe uses everywhere: temperature. It is like being carried, wrapped, through air that is imperceptibly warmer on the side you are moving toward. Like the faintest possible draught you cannot feel and cannot name. Like walking in the very early morning and knowing, without being told, which way the sun is going to come up, because one edge of the world is already a fraction less cold than the other. And from that dipole, you can read the speed. The size of the temperature difference gives it directly, with no distance ladder, no calibration argument, no 30 years of quarreling about the brightness of standard candles. The number that comes out is 370 kilometers per second for the sun's motion relative to that light. Correct for the sun's orbit within the Milky Way and the Milky Way's fall toward Andromeda, and what remains is the motion of the local group as a whole, roughly 620 kilometers per second, pointed toward the southern sky, toward Hydra and Centaurus, which is to say, toward the lean. Two entirely separate methods, sharing no assumptions, using different physics and different instruments and different centuries of thought. One of them counts hundreds of galaxies, estimates their distances by the internal motions of their stars, and subtracts the expansion. The other measures the temperature of an ancient light on opposite sides of the sky. They should have nothing to do with each other. And they point the same way, at the same speed, within the errors. When that happens in science, you can begin to relax about whether the thing is real. Agreement between strangers is the strongest evidence there is. Two people who have never met, who were not in the room together, who used different words entirely, describing the same street corner and getting the furniture in the same places. The universe leans, and the galaxies say so, and the oldest light says so, and they were never allowed to compare notes. Notice what has been established and what has not. We now know, past reasonable doubt, that we are moving, how fast, and in which direction. What we do not yet know is what is at the far end of the direction. That is a very particular kind of knowledge, and it is more common than we admit. You can be certain of a slope without knowing the shape of the valley. You can know that a room is tilted and know which way, and have no idea what is on the other side of the wall. Direction is one question. Cause is another, and harder. For a while, the natural assumption was that the cause was a single thing, a great mass, a concentrated something, sitting at the end of the arrow, doing all of the pulling by itself. That is how the name reads, and it is how the newspapers reported it, and it is how most of us first hear of it, and it is not quite how the universe turned out to be arranged. What lies at the end of the arrow is not one object. It is a landscape, and we will spend the next stretch of tonight walking into that landscape without any hurry at all, because there is no hurry available in a story where the journey takes longer than the age of the universe. Before we go there, take a breath that is deeper than the last one, and let it out more slowly than you took it in. That is all. Let the out-breath be longer than the in-breath, and let the difference between them be where you rest. The ancient light is still passing through you, 380,000 years after the beginning, warm by 0.003 of a degree on one side, and it asks nothing of you, and it has never asked anything of anyone. So let us go there. Let us follow the arrow into the fog and see what the other windows have shown us. 220 million light-years away, give or take, in the direction of the southern constellation Norma, there is a galaxy cluster. It carries the catalog designation Abell 3627, and astronomers usually call it the Norma cluster. And for most of the 20th century it was essentially unknown, because it sits at less than 7 degrees from the galactic plane, deep inside the curtain. In visible light, it is dimmed by a factor of something like 100. It was catalogued, barely, but nobody understood what they were looking at. Then the X-ray sky was mapped, and Norma turned out to be one of the brightest and most massive clusters within a few 100 million light-years of us. Comparable to the Coma cluster, which sits high in the northern sky in clear view and has been famous for a century, Norma had been there the whole time, a giant on our doorstep, invisible for the trivial reason that it lay behind a bank of dust. Let me tell you what a cluster of that size actually is, because the word cluster does not do the work. Take 1,000 galaxies, some of them larger than the Milky Way, ellipticals as massive as anything in the universe, and among them spirals and lenticulars and swarms of dwarfs. Spread them through a volume perhaps 20 million light-years across. Fill the space between them, and this is the part people rarely picture, with gas. Not a little gas. In a cluster like Norma, the hot gas that lies between the galaxies weighs more than all the stars in all the galaxies combined, several times over. It is thin beyond any laboratory vacuum, a few particles per litre, and it is heated to 50 or 80 million degrees, not by any fire, but simply by having fallen inward and had nowhere to put the energy of the fall. That gas glows in X-rays. That glow is the light we found it by. And even the gas and the stars together are not most of it. Weigh the cluster by the motions of its galaxies. Weigh it by the temperature of its gas. Weigh it by how it bends the light of things behind it. And all three weighings agree that something like 85% of the mass is dark matter, some substance that has weight and nothing else, that does not shine and does not absorb and does not touch, that passes through the walls of this room and through your body and through the earth without any interaction beyond its gravity. It is the scaffolding. The galaxies are what settled into it, the way frost settles onto the shape of a window rather than making the window. At the center of Norma, at the very bottom of that well, there is a galaxy called ASO 137-6, an enormous elliptical with a radio source in it, and near it a smaller galaxy that has become one of my favorite objects in the sky. It has an unlovely designation, ASO 137-001, and it is falling into the cluster at something like 2,000 kilometers per second, and as it falls, the hot cluster gas is stripping it. Its own gas is being pulled off it by the pressure of passage, the way smoke is pulled off a moving torch, and that stripped gas is glowing behind it in a tail hundreds of thousands of light-years long, and inside the tail, in the wake, new stars are lighting up. Astronomers call it a jellyfish galaxy. It is losing what it was made of, and the losing is producing light, and the light is new. I will leave that image there, without pressing on it. Some things are better if you are not told what they mean. Now widen out. Norma is not alone. Behind and around it, in the same broad region, there are other clusters: Centaurus, Hydra, Pavo, and a scattering of groups and filaments, all of them threaded together. And when you assemble the peculiar velocities of everything in that neighborhood, what you find is a converging flow, an inward drift from every side, which astronomers named the Norma flow, or sometimes simply the Great Attractor flow. Galaxies on our side are moving away from us and inward. Galaxies on the far side are moving toward us and inward. The pattern is unmistakable. It is a basin. This is the moment when the word attractor should quietly retire and hand the story over to a better word. The word is watershed. Stand on a hillside in gentle rain, somewhere in a wide valley with no dramatic features, and ask where the water is going. Every drop that lands finds a slope. It joins a rivulet, and the rivulet joins a stream, and the stream joins a river. And every drop that fell anywhere in that valley, on any hill, on any roof, on your coat, is going to the same estuary, and none of them was pulled there by the estuary. Nothing at the mouth of the river reached up the valley to take them. There is only the shape of the land, and there is only water doing the one thing water does, which is to go downhill. And the destination is a consequence of the shape rather than a summons from the sea. That is what the Great Attractor is. Not a thing at the end of a rope. A low place in the landscape of gravity. An entire region where the mass happens to be concentrated more than average, and the space around it is therefore tilted inward, and everything within reach of the tilt has been drifting downhill for billions of years without anything ever having reached out for it. And this reframing dissolves the last of the menace in the name. A drain has a mouth. A drain has a rate. A drain empties. This has none of those. The basin is so shallow, in the sense that matters, that our downhill drift is only a few % of the speed at which the universe is carrying everything apart. We are a leaf on a river that is widening faster than we are angling toward the bank. And the destination itself is drifting away from us as the space between grows, so the estuary recedes as the water travels toward it, and there is no arrival written anywhere in the arithmetic. Come back to your room. The floor leans and the low corner is real, and the low corner is 200 million light years away, and everything loose in the room has been rolling toward it since the room was made, at a speed at which nothing rattles, nothing shifts, nothing tips over, and no one who lives in the room will ever see a single object arrive anywhere. It is the least urgent fact in the universe. It is a lean so patient that 13 billion years of it has produced no event whatsoever. There is something worth keeping in that. Not everything that is true about you needs to be attended to. Not every current requires a response. You are being carried in a direction you did not choose and cannot feel and will never arrive at. And this has been the case every second of your life, through every hurried afternoon and every difficult conversation and every night you could not sleep, and it has never once required your cooperation. It did not need you to understand it. It did not need you to notice. It carried you anyway, and it is carrying you now, and it will go on carrying you while you sleep. The watershed idea turned out to be more than a comforting way of speaking. In 2014, a team led by Brent Tully, the same Tully of the rotation relation nearly 40 years earlier, took it literally and made a map with it, and the map changed how we describe where we live. Here is the problem they solved. If you want to say which supercluster a galaxy belongs to, you have to decide what belonging means, and for most of the 20th century belonging meant proximity. Astronomers drew boundaries around visible concentrations of galaxies more or less by eye, the way early cartographers drew countries around the places where the towns were. Our own address, under that scheme, was the Virgo supercluster, a region about 100 million light-years across centered on the Virgo cluster, and the boundary was essentially a judgment call about where the density thinned out enough to stop. Tully and his colleagues, with Hélène Courtois, Yehuda Hoffman, and Daniel Pomerede, proposed something different. Forget the light. Look at the motion. Take every galaxy for which you have a peculiar velocity, and there were now tens of thousands. Subtract the expansion from each, and you are left with a field of arrows, a map of local currents through a volume hundreds of millions of light-years across. Then, ask, for each point in that volume, where the flow at that point is going. Follow the arrows downhill, one to the next, the way you would trace a raindrop from a hillside to the sea. Every point whose arrows lead to the same basin belongs to the same structure. The boundary is not where the light thins out. The boundary is the ridge, the divide, the line along which a drop landing an inch to the left goes one way, and a drop landing an inch to the right goes another. Watersheds. The same definition a hydrologist uses to say where a river system begins and ends applied to the flow of galaxies through the gravitational landscape of the universe, and when they did it, our address got much larger. The Virgo supercluster turned out not to be a supercluster at all, but an appendage, a lobe, one valley among several belonging to a single much greater basin. That basin contains roughly 100,000 galaxies. It measures something like 500 million light-years across. Its total mass is on the order of 100,000 trillion times the mass of the Sun. And the low point of the whole structure, the place where all its arrows converge, the bottom of the valley, lies in the direction of Norma and Centaurus, behind the curtain, exactly where the Seven Samurais' arrow had been pointing all along. They named it Laniakea. It is Hawaiian, chosen with the help of a language teacher at Kapiolani Community College, and it means immeasurable heaven or spacious sky. It was chosen partly in honor of the Polynesian navigators who crossed the largest ocean on Earth by reading swells and stars and the flight of birds, holding an entire sea in memory without instruments. And that is exactly the right lineage for a map made out of currents rather than landmarks. So this is the address you fall asleep at tonight. A planet orbiting an unremarkable star, about 26,000 light-years out from the center of a barred spiral galaxy, which is one of about 80 in a bound local group, which lies in a filament, which lies in a lobe called Virgo, which is one part of a vast basin called Laniakea, whose floor slopes toward Norma, and all of that is one of the many basins that make up the visible universe, of which there are countless others we can see, and more we cannot. Now, an honest word, because the science here is real science, and real science has edges. Laniakea is a definition, not a discovery of a solid object. The boundary depends on the velocity data you feed it, and on how you smooth that data, and different teams drawing the divide with different methods place it somewhat differently, and some argue it is not gravitationally bound as a whole and will be pulled apart by expansion long before it could ever collapse into anything. That is not a weakness in the result. It is the result being described accurately. A watershed is a real feature of a landscape and also a human way of grouping slopes, and both of those things are true of a river valley on Earth, and nobody feels cheated by the Thames. But I want to give you the picture, because the picture is worth carrying into sleep. Imagine you could see gravity as terrain, not stars, not galaxies, No light at all. Just the shape of space itself, rendered as a landscape. Mass makes valleys, emptiness makes highlands, and the whole thing rolls away in every direction. From high above, Laniakea looks like a river delta seen from an aeroplane at the end of a long flight. When you have been half asleep for hours, and you lift the blind, and there below is an enormous silver branching, tributaries feeding tributaries, threads combining into channels, everything drawn downward by a slope too slight to see. The whole pattern legible in a single glance, even though no single drop of it knows where it is going. That is a map of us. Those threads are filaments of galaxies. Those channels are the flows. And somewhere on one of the smaller tributaries, so far up the system that it would not be marked on any chart, is a galaxy. And in one of its arms is a star, and around the star is a small, wet planet, and on the planet is a room, and in the room is you, lying down, breathing out. There is a particular quality to being small inside something that large, and I do not think it is diminishment. Diminishment is what happens when you are made small by comparison with something that is competing with you. This is not that. The delta is not competing. Nothing in Laniakea is keeping score, and nothing in it is indifferent either, because indifference requires a mind that has chosen not to care. There is no one at the bottom of the valley. There is only a slope, and the slope holds everything on it without effort and without preference. The largest cluster and the smallest dwarf galaxy and the water in your cells. All of it leaning the same way at the same speed. None of it asked to be here. None of it asked to leave. Being small in a large system is what being held feels like when the system is not a person. And here is a detail that I find harder to shake than any of the numbers. The flows that Tully mapped are, in a sense, a memory. The pattern of motion we see now is the accumulated answer to a distribution of mass that was laid down in the first fractions of a second after the beginning, when quantum fluctuations, random and unbelievably tiny, were stretched by the sudden inflation of space into faint variations in density spread across the whole cosmos. Slightly more here, slightly less there. Parts in 100,000, the same magnitude as the ripples in the background light. Everything since has been gravity patiently amplifying that first faint unevenness. The places with a fraction more matter pulled a little harder, and grew and pulled harder for having grown. 13.8 billion years of that, and the parts in 100,000 became filaments and voids, and clusters and superclusters, and the low corner of our room, and the direction of our drift, and the delta seen from the aeroplane window, which means the lean in the floor was set before the floor existed, before stars, before atoms, before light could travel at all, in a moment that lasted less than the time it takes a nerve to fire. The shape of everything that would eventually carry you was already faintly sketched, and it has been unfolding at the pace it chose ever since, without ever once being in a hurry, without ever once needing to be finished. Let us stop explaining for a while. We have been walking through the room measuring the lean, and now I would like you to simply lie on the floor of it. Imagine that you are being carried, not moved, not sent. Carried, the way something small is carried by something large that has no opinion about it. Begin with what is true. You are lying down. Beneath you, whatever surface is holding you completely, and you are not doing any of the work of that. Beneath the surface, the floor. Beneath the floor, the building, the ground, the rock, the long cool depth of the planet's crust, and the slow enormous churn beneath it. All of that is turning, a little under half a kilometer every second at the equator, less where you are, and you have never fallen off, and you have never held on. And that turning planet is traveling around the sun at about 30 kilometers per second. An entire ocean and every mountain and every person swinging through a curve so wide that in the course of tonight you will trace an arc 1,000,000 kilometers long and not one glass of water anywhere will spill. And the sun, with all of us threaded behind it, is traveling around the center of the Milky Way at roughly 230 kilometers per second, and has done so for 4.5 billion years, and in all of that time has completed the circuit perhaps 20 times. The last time the sun was in this part of its orbit there were no flowers on Earth. It is that slow, and it is that fast, and both are true at once, and neither one is anything you can feel. And the Milky Way is falling toward Andromeda, and the whole local group is leaning toward Norma, and all of it together is drifting through the ancient light at 620 kilometers per second, warm by 0.003 of a degree on the leading side. Every one of those motions is happening to you right now, layered, one inside the other, like the sea inside the tide, inside the current, inside the turning of the whole ocean, and not a single one of them is available to your senses. There is no vibration. There is no drought. There is no sound of passage. The room is level. The water in the glass on the table beside you does not tremble. Let the imagining widen now, and let it be easy, and if you drift away in the middle of it, there is nothing to come back for. Imagine you are lying not on a bed, but on a raft, on water so wide there is no shore in any direction, and never was. The water is not cold, it is exactly the temperature of the air, which is exactly the temperature of your skin, so that the edge between you and the world has gone soft, and there is no line where you stop. There is no wind. The surface does not chop or slap. It moves, but it moves the way something moves that has been moving since long before you arrived, a swell so long and so low that a whole minute passes between one crest and the next. It lifts you. It sets you down. It lifts you again, and each lift takes so long that it is less like being rocked than like being breathed by something enormous and unhurried. You are traveling. You know this, though you cannot see it, because there is nothing on the water to measure yourself against. No buoy, no wake, no far bank. The current beneath you is broad and deep, and it has a direction, and you are in it, and you have been in it since before you could remember anything, and it is taking you somewhere it will take 100 billion years to reach. Nothing you do makes the slightest difference to the current. This is not a failure. You could swim as hard as anyone has ever swum, in any direction, and the current would carry you at exactly the same speed toward exactly the same place. And you would arrive not 1 hour earlier or later. And equally, you could do nothing at all, as you are doing now, as you are entitled to do now, and the current would carry you just the same. Effort and rest are identical here. The river does not check. So let the arms be heavy. There is nothing to row with, and nothing to row toward. And the raft is warm on one side, only a little, only on the leading edge, the side facing where you are going, and only by an amount you could never truly detect. But let yourself imagine it anyway, the faintest possible warmth, ahead of you, as though somewhere impossibly far in that direction the sun rose long ago, and what reaches you now is not light, but the last mildness of it. That warmth is 13.8 billion years old. It has been traveling for the entire history of everything to arrive on that one side of you tonight. Above, there is nothing to look at, and that is a relief. No stars in this imagining, just an evenness, dark and complete, at the same temperature as everything else. When there is nothing to look at, the eyes stop searching, and when the eyes stop searching, the small muscles around them let go. And you can feel that letting go as a kind of downward settling behind the face. Now let the raft go too. You do not need it. The water holds you without it. Let the boundaries of your body become approximate, the way they do just before sleep, when the hand you thought was at your side turns out to be somewhere else entirely, when the size of you becomes a rumor rather than a fact. You are being carried through the oldest light in the universe at 620 kilometers per second toward a low place 200 million light years away that you will never reach and that was never waiting for you. And nothing is asked of you. That is the part I keep wanting to hand you. In a story this large, there is no role for you to fill, no vigilance required, no contribution expected, no moment at which someone will need you to be awake. The drift does not need a witness. It ran for 9 billion years before the Earth condensed, and it did not once falter for lack of anyone watching, and it will run for 100 billion more after everything anyone has ever built has been forgotten, and it will not falter then either. You are, tonight, entirely surplus to the operation of the universe, and that is the most restful sentence I know how to say. Stay on the water as long as you like. The swell lifts and sets you down and lifts again, a minute between one and the next, unhurried, 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 and the warmth is on one side, and the current has you, and there is nowhere to be. When you are ready, and there is no need to be ready, we will go one step further out, because the story has a turn in it that nobody expected, and it is a turn worth knowing. Through the 1990s, as the surveys improved, astronomers began to check the arithmetic of the basin. If Norma and its surroundings really are the source of our drift, then the mass in that region should be enough to produce the speed we measure. So they counted. They weighed the clusters by their X-ray glow and by the motions of their galaxies. They added up everything they could find within about 250 million light years in that direction. And it was not enough. Perhaps half of what was needed. Maybe less. Something further away was contributing. And when they looked further along the same line, past Norma, 4 times as far, they found what had been there in the catalogs since the 1930s without anyone realizing what it was. Harlow Shapley, working at Harvard in the years when the nature of galaxies was still being argued about, had noticed an unusual density of faint nebulae in the direction of Centaurus. He wrote it up. It was a curiosity, a cloud of smudges in a region of sky, and there was no framework yet in which it could mean anything, so it sat in the literature for 50 years. It is now called the Shapley supercluster, and it is the largest concentration of mass in the nearby universe. 650 million light years away, roughly in the same direction as the Great Attractor, and beyond it, it contains more than 20 rich galaxy clusters and something on the order of 10,000 galaxies. And its total mass may be 10 times that of the Great Attractor region itself. Distance weakens gravity by the square, so being 4 times further away costs Shapley a factor of 16. But being perhaps 10 times more massive buys much of that back. And so the current estimate, and it is an estimate with real uncertainty attached, is that our drift is not the work of one basin, but of a slope with more than one contributor. Something like 1/3 to 1/2 of it comes from the Great Attractor region and the mass in and around Norma. A comparable share, perhaps more, comes from Shapley, pulling from far behind it. and the remainder comes from the general lumpiness of everything else out to great distances. A faint summed tilt from directions in every part of the sky, most of which cancel, and a little of which does not. So the picture we ended up with is not the one the name promised. There is no single great thing. There is a nearby dip that we are in, and a much deeper valley far beyond it in the same direction, and the two of them together, along with 1,000 smaller irregularities, make a slope. The floor of the room leans, and the lean is the sum of everything heavy in the neighborhood, and no single item of furniture is responsible. I like this ending to the question far better than the one we were expecting, and I want to say why. Because it is the kind of thought that is good to fall asleep on. We are extremely good at looking for the single cause. When something moves, we want the mover. When there is an effect, we want the agent, the one thing that did it, the culprit, the reason. It is how we are built, and it has served us well. But most of what actually shapes a life is not like that. Most of it is a slope made of many small, unremarkable weights, none of which would be worth naming, none of which is the reason, all of which together decide which way things go, where you were born, and who spoke to you kindly on some ordinary afternoon, and the book someone left out, and the road that happened to be closed. There is no great attractor in any life. There is a landscape made of everything, and the drift is the sum. And nobody in the story is at fault, and nobody is in charge, and the arithmetic still comes out to a direction. There is one more thing that Shapley gives us, and it is a strange and lovely detail. Because Shapley sits so far away, and because our drift toward it is so slow, and because the expansion of the universe is accelerating, Shapley is one of the clearest examples of a destination that is receding faster than we approach. Dark energy, whatever it is now the dominant influence on the largest scales, and it works against every gravitational basin that has not already collapsed. Structures that are bound will stay bound. The local group will hold. Norma will hold. Shapley will hold. But the space between the bound things is widening at an accelerating rate, and it will keep widening. And the great flows we have spent tonight describing are, in the long run, being switched off. We are in the last era in which this is even measurable. In 100 billion years, an astronomer in whatever the local group has become, and by then the Milky Way and Andromeda, will have merged into a single elliptical galaxy with no arms and no name we would recognize, will look out and see nothing but their own merged home, and the rest of the sky will be dark, every other galaxy carried beyond the horizon of what light can cross. They will have no way to discover any of this. The evidence will have left. Which means that the fact you are being told tonight is a fact available only for a while, in a particular window of cosmic time, to a species that happened to develop telescopes during it. That is not a sad thought, or it need not be. It is closer to the feeling of being awake at an hour when almost nobody is, and knowing that the light on the street will look this way for another 20 minutes and then not again. And what is left, when the flows switch off and the sky goes dark, is not a collapse and not a catastrophe. It is separation, and then quietness, and then a very long time in which everything that is bound remains bound, holding its own shape, indifferent to a universe it can no longer see. The room stops leaning because the room becomes only the corner you are in, and the corner is level, and everything in it stays. None of that is tonight's problem. It is nobody's problem, and it will not be for 100 billion years, and by every measure available it is the least urgent piece of information in existence. I mention it only because it completes the shape, and because a story with an ending is easier to set down than a story without one. The lean is real. The lean will fade. Nothing arrives. Nothing is lost. And in the meantime, tonight, you are being carried at 620 kilometers per second toward a place made of 2 valleys and 10,000 small weights, and you have never had to think about it before, and you may put it down again as soon as you like. I promised, at the beginning, that we would spend a long while with what remains unknown, and that we would do it honestly. The title of tonight is not what we know about the Great Attractor. It is what we do not. So let us walk through the open questions without rushing any of them toward an answer, and let us treat each one as a place to rest rather than a problem to solve. The first unknown is the simplest and the most stubborn. We do not know how much mass is hidden behind the plane of our own galaxy. Every survey through the zone of avoidance has found more than the last. Infrared surveys found galaxies. Radio surveys found more. X-ray surveys found clusters nobody had cataloged. In 2016, a survey with the Parkes telescope found nearly 900 previously unknown galaxies in that band, and hundreds of them had never been seen at any wavelength by anyone. The curtain keeps yielding. And each time it yields, the accounting of the local gravitational landscape shifts a little, and the share attributed to Norma against Shapley against everything else moves with it. We are drawing a map of a basin, while some fraction of the basin is under cloud, and we do not know precisely what fraction. The second unknown is about convergence, and it is more interesting than it sounds. If you measure the drift of galaxies within a sphere of a given size, and then you make the sphere larger, and larger again, the measured drift should eventually settle. At some scale, the universe should look uniform enough that adding more volume stops changing the answer. Cosmologists expect that to happen somewhere around 300 million light-years. But several surveys of peculiar velocities have found that the flow does not seem to settle where it ought to. Some analyses report a coherent motion persisting out to 400 million light-years and beyond, larger than the standard model comfortably predicts. Other analyses, using different data and different methods, find nothing unusual at all. The disagreement is live. It is not a scandal and it is not a crisis. It is a measurement at the edge of what current data can resolve, and the honest position is that the community has not settled it. The third is the one that got the headlines and then got smaller, and it deserves telling because it shows how science handles an interesting claim. In 2008, a group led by Alexander Kashlinsky reported evidence for what they called dark flow, a motion of galaxy clusters detected through their imprint on the microwave background that seemed to extend far beyond any structure that could account for it, as though the whole observable neighborhood were sliding towards something outside the visible universe entirely. It was a wonderful idea. It suggested that the pattern of matter beyond our horizon was leaving a fingerprint on our side of it. And then, better data arrived, principally from the Planck satellite, and the significance faded. Most cosmologists now regard the effect as unconfirmed and probably absent. That is not a failure. That is the machinery working. A claim was made in the proper way, it was testable, it was tested, and it did not survive, and the people who made it were not wrong to make it. The fourth is dark matter itself, which is the largest ignorance in the whole account. Everything we have said tonight about the shape of the landscape rests on the assumption that most of the mass making the landscape is a substance nobody has ever detected directly. We know its gravitational effects with great precision in clusters, in the rotation of galaxies, in the bending of light, in the pattern of the ancient background. We do not know what it is. Decades of experiments in deep mines and under mountains have not caught it. The particle is not in any accelerator's results. It is entirely possible that the answer is not a particle at all, but a modification to the way gravity behaves at very low accelerations, and though most of the evidence sits against that, most is not all. So the correct summary of the Great Attractor is this. It is a slope produced mainly by a substance we cannot identify, concentrated in a region we cannot see through, at a magnitude we cannot yet fully account for, and we know it is there because everything nearby agrees about which way is downhill. I would like to make an argument now for how good that sentence is to fall asleep on, because I suspect the instinct is to hear it as unfinished. We have been trained, most of us, to treat not knowing as a debt. Something owed. An itch. A gap in the record. A task on a list that has not been ticked. And there is a place for that feeling. It is the engine of every survey and every long night on every mountain. But it is not the only relationship available with the unknown, and it is a poor one to take to bed. Consider how much of your own life you have never known, and how little it has cost you. You do not know what most people think of you, and you have gone on being loved anyway. You do not know how any of the machinery beneath your skin is doing its work at this moment. The enzymes and the ion channels and the astonishing coordinated business of a body, and it has proceeded without your supervision every second since before you were born. You do not know what tomorrow contains. You have never known what tomorrow contains on any night of your life, and every one of those nights ended in sleep anyway. Not knowing is the ordinary condition. It is the water. Knowing is the rare and lovely exception, the small lit patch, and the patch does not have to grow tonight. And here is the thing about this particular ignorance, the one at the far end of our drift. It is entirely without consequence for you. If astronomers resolve the mass budget of the Great Attractor next year, nothing in your body will alter. If they never resolve it, nothing will alter either. You will be carried at exactly the same speed, in exactly the same direction, held on exactly the same floor, whether we understand it or not. The universe has never once made its behavior conditional on being understood. There is an old and specific comfort in that, and it is a comfort that does not require you to be interested in astronomy. The things that hold you up do not need your comprehension. The chair takes your weight before you have thought about the chair. The floor was there before anyone measured it. Breathing has been happening all evening, at whatever rate it chose, without a single instruction from you. And it is happening now, and it will keep happening through the whole of the night while you are entirely absent from the room, in the way that sleep makes you absent. So we can leave the question open. It is genuinely open. 40 years of very good people with very good instruments have narrowed it and not closed it, and there is a real possibility that it will not be closed in your lifetime or mine. Let it stay open. An open question is not a door left ajar in a cold house. It is more like a window in summer. It is a way of being connected to something larger that you are not required to manage. The Great Attractor will go on being partly unexplained tonight, and the galaxies will go on agreeing about which way is downhill, and the fog will go on being made of our own home, and none of it, not one part of it, needs you tonight. I want to spend a while now on scale itself, because we have been throwing numbers around for hours, and numbers of this size do something particular to a person, and I would like to steer what they do. 500 million light years, 100,000 galaxies, 620 kilometers per second, 13.8 billion years, 10,000 trillion suns. These are not quantities anyone can hold. The human capacity for number runs out early, somewhere around 4 or 5, past which we are estimating rather than perceiving. Everything beyond that is a symbol we manipulate rather than a thing we grasp. Nobody has ever pictured a billion of anything. What we picture is a lot, and then we attach a label. So there is no point pretending. You will not comprehend Laniakea tonight, and neither will I, and neither will the people who mapped it, who will tell you as much if you ask them. Comprehension is not on offer. What is on offer is something else, and it is better, and it is available to a mind that is already 3/4 asleep. Try this instead of comprehension. Try proportion. The Earth is small compared with the Sun, that you can almost picture a marble and a beach ball at the right distance apart, which turns out to be about the length of a football pitch. The Sun is small compared with the galaxy, a grain of sand in something the width of a continent. The galaxy is small compared with the local group, and the local group is small compared with Laniakea, and Laniakea is small compared with the observable universe, and the observable universe may be small compared with whatever there is. At every step, the same relationship holds, and it holds so consistently that the relationship itself becomes the only thing worth noticing. Everything is small inside something. There is no level at which the pattern stops, in either direction, up or down. Go the other way and the cells in your finger are small inside the finger, and the proteins inside the cells, and the atoms inside the proteins, and the vast emptiness inside each atom, where the nucleus is a fly in a cathedral and everything else is field. You are not the small thing in a universe of large things. You are one rung on a ladder made entirely of rungs, and nobody on the ladder is at the wrong height. And here is the piece I find genuinely consoling, and I offer it without insisting. Scale does not confer importance in either direction. It is tempting to think that the largest thing matters most, that being enormous is a kind of authority, that Laniakea outranks you because it is bigger. But size is not a moral quantity. A galaxy cluster is not wise. A supercluster has no opinion. All of that mass, all 100,000 galaxies, all those trillions of suns, has never once had a thought, never noticed anything, never preferred one outcome over another, never loved anybody. And you, at the scale of a person in a room, weighing rather less than 100th of a millionth of nothing on any cosmic accounting, are at this moment thinking about superclusters. The universe is very large, and mostly it does not know it. And then, in an unremarkable spiral galaxy on an outer arm, some of it briefly does. You are the part where the room notices the lean. That is not a claim that you are important to the universe. The universe is not the kind of thing that has importances. It is a planar observation. Thinking is not distributed in proportion to mass. And by that measure, the ordinary business of lying in a room at night wondering about things is one of the rarest events available anywhere. But I do not want to leave you with grandeur either, because grandeur is not restful. Grandeur asks for a response. It wants you to be moved, and being moved is a form of work. And at this hour, I would rather hand you something that requires nothing. So let me put it as plainly as I can. There is a slope. It is very old, and it was laid down before there was anything to slope. Everything within reach of it leans, and the leaning is even and undramatic, and has never accelerated or slowed. It carries clusters of galaxies, and it carries individual stars, and it carries the water in a glass on a bedside table, and it carries you. at the same speed, in the same direction, with the same indifference to whether any of you noticed. You did not have to earn that carrying. You did not apply for it. It did not begin when you were born, and it will not end when you stop, and there is nothing you could do to be excluded from it. It is the most unconditional thing there is, and it is unconditional not out of generosity, but because it is not the kind of thing that has conditions. Most of what holds a person up in a life has to be maintained. Relationships need tending. Work needs doing. Even a body needs feeding and moving and repairing. And it can begin to feel, especially at this hour, especially on the nights when sleep will not come, as though everything that holds you requires something back, and as though you are behind on the payments. The lean of the floor requires nothing back. It has never required anything from anyone. It held the trilobites, and it held the dinosaurs, and it held everyone who has ever lain awake in every century. And it did not ask any of them how their day had been, and it did not ask them to be better, and it did not stop when they failed at things. Whatever you did today, or did not do, or should have done and did not, you were carried at 620 kilometers per second throughout, without interruption, without judgment, and you are being carried now. Let that be enough of an idea for a while. Let the numbers go. You do not need to retain any of them. There will be no examination. The figures were only ever a way of pointing, and now that we have pointed, the finger can be lowered. What is worth keeping is not a number. It is a posture. It is the sense of being one of the many things on a leaning floor, in good company, in no hurry, going somewhere that will never be reached, in a room so large that the walls are a rumor. And your shoulders, again, a little further down. Your jaw unclenched again, because it will have crept back. The tongue resting away from the roof of the mouth. The space between your eyebrows widening. The out-breath longer than the in. There is one more stretch of the story I would like to tell before we begin to close, and it is about what happens next. Which is to say, about people who are awake right now doing this work. Somewhere at this moment it is not night. On a ridge in the Atacama, in air so dry that the instruments have to be warned about it. A dome is being closed against the daylight while somebody writes up what the night produced. In Western Australia, on a plane kept radio silent by law, thousands of small antennas that look like nothing at all, like metal weeds, are listening at wavelengths that pass through dust as if it were not there. In New South Wales, the Parkstish, 64 meters of steel that has been turning since 1961, is doing what it has done for 6 decades. In orbit, satellites are counting X-ray photons one at a time, each one a message from gas that fell into a well 100 million years before there were people. The instruments coming now will make tonight's uncertainties look quaint. Radio arrays are being built that will map neutral hydrogen across the whole southern sky, including every degree of the zone of avoidance, cataloging hundreds of thousands of galaxies and measuring their redshifts as a matter of routine. Space telescopes are surveying enormous volumes to trace how structure grew. Spectroscopic instruments with thousands of individual fibers, each one aimed at a separate galaxy, can gather in a single night what the 7 samurai gathered in a year. And with better distances come better peculiar velocities, and with better peculiar velocities comes a better map of the slope, and somewhere in the next decades, the mass budget of our local basin will be closed, and someone will be able to say with confidence how much of our drift belongs to Norma and how much to Shapley, and how much to the summed weight of everything else. I find it restful to think about that work continuing while I sleep, and I offer the thought to you. Because this is one of the few human projects that genuinely does not stop. It has been running, in one form or another, since somebody in Babylon started keeping a record of where Venus was on which night, and kept it for long enough that the record outlived them, and then somebody else continued it. Nobody who began the measurement of the sky lived to see any of it finished. Every single person who has contributed to this has handed unfinished work to a stranger, and every one of them knew they were doing that, and they did it anyway. There is a version of that thought which is melancholy, and I do not think it is the true version. The true version is closer to a relay, or to a wall built over 300 years by masons who never met, each course laid on the last, no one of them responsible for the whole. Alan Dressler and Sandra Faber and the others did not solve the Great Attractor. They noticed a residue in a table of numbers. Then, René Cron-Corteveg and others spent careers pushing back the curtain in the zone of avoidance. Then, Tully and Courtois and Pomered drew the watershed. And it goes on now with people whose names are not yet attached to anything, some of whom are undergraduates tonight, some of whom have not been born. You are allowed to hand things over unfinished. This is the largest and most successful ongoing project our species has, and its entire method is handing things over unfinished. So let the day you did not finish be unfinished. Let the conversation you did not complete stay incomplete overnight. Let the thing you meant to do stay undone until morning, and let it be undone in good company. Alongside a 40-year-old question about the mass distribution behind the plane of the Milky Way that has been left overnight thousands of times by thousands of people who were better at it than any of us, and who went to bed. And there is one more thing about this work I would like you to have, which is the physical texture of it. Because it is unexpectedly soothing. Astronomy is mostly waiting. It is a discipline of long exposures. To photograph something faint, you open the shutter and you hold it open, and the fainter the object, the longer you hold, and there is nothing to do during the holding but keep the telescope pointed and let the photons arrive at whatever rate they choose. Some of the deepest images ever taken required weeks of accumulated exposure spread across months. The picture does not appear and then improve. It emerges from noise, slowly, the way a face emerges in a darkroom tray, present the whole time, waiting for enough of it to have arrived. There is no way to hurry a photon. That is the whole constraint of the field, and it makes astronomers, as a group, unusually good at patience. The light left the Norma cluster 220 million years ago. It has been crossing empty space every second since, through the Triassic and the Jurassic, through the arrival and departure of everything, and it arrives tonight, at a particular mirror on a particular mountain, at exactly the rate it always intended, and no amount of wanting it sooner has ever made the slightest difference. Let that be the pace of the rest of the night. There is nothing here that can be hurried, and nothing here that needs to be. The photons arrive at their rate. The breath arrives at its rate. Sleep arrives at its rate, and it has never once been made to come faster by being asked, and it does not need to be caught, only allowed. Come back to the room one final time before we close. The room you are actually in, with its actual corners and its actual air. The floor beneath it leans by a fraction of a hair across a width you cannot see the end of, and it has leaned that way since before the atoms in the walls were made, and everything loose in the room has been answering the lean for 13 billion years without a sound. You are one of the loose things. You are answering it now at 620 kilometers per second, lying down, doing nothing, breathing out. Before the closing, one small return, and it is a return inward rather than outward, because we have spent a long time looking 200 million light years away, and there is something worth noticing much closer to home. All of this drift, all 620 kilometers per second of it, is a motion of the local group as a whole, and the local group is a bound thing. That word is doing quiet work, so let me unpack it and then let it go. To be bound means that the expansion of the universe does not apply to you. The stretching of space happens between things that are not held together, and it has no power over anything whose own gravity has already won the argument locally. The local group won that argument long ago. So the Milky Way and Andromeda and Triangulum and the 80-odd dwarf companions are not receding from one another and never will. They are a household. The room may lean, the room may be carried, the room may be part of a delta of 100,000 galaxies, but the household inside it stays intact, and stays intact permanently. And within that household, the members are moving toward one another. Andromeda, 2.5 million light years away, the furthest thing any unaided human eye can see, a faint elongated smudge in the autumn sky that looks like a thumbprint on the glass, is approaching us at about 110 kilometers per second. In roughly 4 billion years, the two galaxies will begin to pass through one another. And that, too, is not a catastrophe, which is worth saying because it is usually told as one. Galaxies are mostly empty. The distance between stars, compared with the size of stars, is so extreme that when two galaxies collide, essentially no stars hit anything. The sun, if it is around, will not be struck. What happens instead is that the gas clouds meet, and where gas meets gas at speed, it compresses, and where it compresses, it forms stars. And the merger of the Milky Way and Andromeda will produce, for a few 100 million years, one of the brightest star-forming events in this part of the universe. The two spirals will lose their arms. They will settle over billions of years into a single large elliptical, smooth and old and calm-featured, and it will drift on toward Norma with everything else. There will be nobody on Earth to see it, and not because of the merger. The sun will have swollen, and the oceans will have gone 1 billion years before, for reasons that have nothing to do with any of this and are equally not tonight's business. But I like knowing the shape of it. Two enormous things, approaching for billions of years, meeting without a single collision, and the result is more light than either had alone. And beneath the household there is the household's own furniture, and it is the closest layer of all. Around the Milky Way, there are dwarf galaxies, dozens of them, some of them so faint they were found only in the last 20 years by noticing that a handful of stars in one direction were moving together. The Magellanic Clouds, visible from the southern hemisphere as two detached scraps of the Milky Way, are among them, and they are shedding a stream of hydrogen behind them as they orbit, a bridge of gas thousands of light years long, invisible to the eye and obvious to a radio telescope. And within our galaxy, the sun has its own local situation, a bubble of hot, low-density gas hundreds of light years across, blown out by supernovae that went off millions of years ago, and we are inside it, and we have been inside it the whole time our species has existed, and nobody knew until we could measure the soft X-ray glow of its walls. layer inside layer inside layer. And every layer discovered by someone patiently noticing that a set of numbers agreed with each other. I tell you this now, at the end, because I do not want to leave you only with the very large. The very large is impressive, and it is not where anyone lives. You live in a room, in a household, in a bubble, in an arm, in a galaxy that is going to merge with its neighbor and make new stars in the process. Each of those is a nested holding. Each one is a thing that stays intact while the larger thing carries it. That is the whole architecture. Bound things, held inside drifting things, held inside expanding things. Nothing that is together is being pulled apart. Only the empty space between the separate things is growing, and empty space has never been anybody's home. There is one last image I want to give you before the closing, and it is the smallest one of the night, and it belongs to the room rather than the sky. Think of a very old house on a hillside, the kind that has settled over 2 or 3 centuries into the ground beneath it. Somewhere in that house there is a door that will not stay open, or will not stay shut, and everyone who lives there knows it, and nobody thinks about it. A marble set down on the kitchen floor will find its way, without hurry, to the same place under the dresser it always finds. The house is not falling down. The house is not in danger. It has simply been leaning for longer than anyone alive, and the lean has become part of how the house is lived in. Unremarkable, accommodated, almost affectionate. Nobody in that house lies awake because of the slope. They know it, and knowing it costs them nothing, and it has never once woken anyone. That is the relationship I would like you to have with everything we have said tonight. Not awe, exactly. Awe is a bright feeling, and bright feelings keep people up. Something more like the way you know the floor of an old house. A fact about where you live, held loosely, requiring no maintenance, faintly pleasing when it happens to cross your mind, and entirely absent from your mind the rest of the time. Because that is what it will become. Tomorrow, or some evening next week, you will be doing something entirely ordinary, washing up, or standing at a bus stop, or waiting for something to heat, and it will cross your mind that you are leaning at 620 kilometers per second toward a place behind the dust in the southern sky that nobody can properly see. And it will not stop you, and it will not move you particularly, and it will not need to. It will be a fact about the house. And then it will go again, and you will finish the washing up. There is a whole category of knowledge like that, and I think it is the best category. Things that are true, and large, and not urgent. Things that do not ask to be acted on. Most of what we take in during a day is the opposite. Information that arrives with a demand attached, that wants a decision, or a reply, or a worry. And it accumulates, and by the end of the evening, a person can be carrying a great deal of that, and not be able to put it down, which is often what is happening, when sleep will not come. So consider tonight a deposit in the other account. 400 galaxies agreeing about downhill. A cluster hidden behind ash. A phrase, zone of avoidance, that is really a portrait of the mapmaker. A word, Laniakea, borrowed from navigators who crossed an ocean by reading swells. An estuary that recedes as the water travels toward it. None of it needs anything doing about it. None of it will still be a problem in the morning, because none of it was ever a problem. And all of it is happening, whether attended to or not, at exactly this moment, in a direction just below the southern horizon from most of the places people live, at a speed that has not varied while you listened. Somewhere on a mountain in Chile, a dome is open. Somewhere on a plain in Australia, a field of metal antennas is listening at 21 centimeters to a galaxy nobody has catalogued yet. And here, in this room, the lean continues, and the breath continues, and neither one is being supervised. And now we come to the end, and we will come to it slowly, the way you come down a staircase in the dark when you know the house. Tonight has been about a lean in the floor. Tonight has been about 7 tired astronomers on cold mountains, measuring 400 galaxies over 6 years, and finding that the leftovers of their arithmetic agreed with one another. Tonight has been about a band of dust across the sky that we named the zone of avoidance, as though the sky had made a decision, when the truth was only ever a fact about where we happen to stand. Tonight has been about an ancient light that fills every cubic centimeter of everything and is warmer by 0.003 of a degree on the side we are traveling toward. Tonight has been about a cluster called Norma that was a giant on our doorstep for the whole of human history and went unseen because of ash. Tonight has been about a basin and a watershed and a delta seen from an aeroplane window at the end of a long flight. Tonight has been about Laniakea, immeasurable heaven, 100,000 galaxies all leaning the same way. Tonight has been about Shapley, further out and heavier, adding its share to the slope. Tonight has been about everything we do not know, which is most of it, and which we'll keep. And underneath all of it, tonight has been about being carried. You are being carried. You were being carried this morning, through whatever the morning was. You were being carried this afternoon, through the part of it you would rather not think about. You are being carried now. Nothing arrives. Nothing collides. Nothing is consumed. The floor leans. The room is enormous. The low corner is 200 million light years away, and no one is waiting there. You did not earn the carrying. You cannot lose the carrying. There is no way to be excluded from it. The photons arrive at their rate. The breath arrives at its rate. Sleep arrives at its rate. And none of this needs anything from you tonight. Not your attention, not your understanding, not your memory of a single word of it. You do not need to remember what Laniakea means, or how far Norma is, or which 2 names were joined to the rotation relation. You do not need to have followed the physics, and you do not need to have stayed awake. And if you have been asleep for an hour already, then this has been said over you rather than to you. And that is exactly as it should be. And it worked. The universe has never once made its behavior conditional on being understood. The lean does not check whether you were listening. It held the trilobites, and it will hold you tonight, and it will still be holding you at 4 in the morning if you wake, and it will be holding you when you wake for good. If this helped, the next one will begin on its own in a moment, and you do not need to do anything for that to happen. Let it play. If your eyes are closed, leave them closed. If your hand is somewhere far away and heavy, leave it there. And if you would like these to keep finding you at this hour, a like or a subscribe is enough, and can wait entirely until morning, or never. Nothing here depends on it. And if you find yourself awake enough to want to leave something behind before you go, here is the question I have been holding all night. What is the largest thing you have ever felt held by? Not the most impressive thing you have seen. The largest thing that made you feel held. A landscape, an ocean, a piece of music, a room, a person, a night sky from somewhere with no lights. Leave it below if you like, and I will read it, and other people lying awake at this hour will read it too. And there is something in that. Strangers at 3 a.m. telling each other what held them. But that is for later. Not now. Now, let everything come down. Let your attention leave the sky. It has been out at 200 million light years for a long time, and it is allowed to come home. Bring it back past Shapley, past Norma, past the curtain of dust, back through the local group, back into the Milky Way, back along the arm, back to the small warm planet, back into the country you are in, back into the building, back into this room, back into the bed, back into the body, and now inside the body. The forehead. Let the skin across it widen the way it does when someone tells you the thing you were worried about is fine. The space between your eyebrows, unfolding, the eyes. Let them be heavy in their sockets. There is nothing left to look at. The eyes can stop pointing at things. The jaw. It has crept back up again since the last time. Let the back teeth part. Let the tongue rest low and away. The throat and the front of the neck, which holds more than anybody notices. Let it be undefended. The shoulders. Down and further down and further than you thought was available, away from the ears, out toward the sides. The arms, heavy from the shoulder to the elbow, heavier from the elbow to the wrist, and the hands entirely done for the night. The fingers uncurled. Whatever they were holding, they are not holding it now. The chest. Let the breath come in without being asked, and let it go out slower than it came in, and let the out-breath be where you rest. The belly, unbraced. Let it be round and easy and not held in for anyone. The hips, heavy, the whole weight of you handed over to whatever is underneath you. It can take it. It has been taking it all along. The thighs, the knees, the calves, the ankles, heavy and warm and further away than they were a minute ago. And the feet last and completely. You are lying down, in a room, on a planet turning at a few hundred meters a second, going around a star at 30 kilometers a second, going around a galaxy at 230, leaning with 80 galaxies toward a basin in Norma at 620, warm by 0.003 of a degree on the leading side, moving through the oldest light there is, held on a floor that has leaned in the same direction since before there were atoms, arriving nowhere, at no particular hour, with nothing left to do. The swell lifts you, and sets you down, and lifts you again, a minute between one and the next. Unhurried, nothing is asked of you. Nothing arrives. You are being carried. Sleep well.